What we're working out in this video is the one example of a cube root that Napier writes up in his Rabdology. It's a huge number, 22,635,627. I think he used such a large number so that he could show the pitfalls that you could run into and help you avoid them. And that's why he used this as an example. Now, I highly recommend that you watch my previous videos on taking a cube root using Napier's method, because this one is going to be quite involved and quite complicated. So do make sure you know the background before you dive into this one. Normally, when I work with Napier's bones, I keep it in the frame because I've got this handy index right on the side, and the top and the bottom keep everything kind of lined up. But with a number this large, I'm afraid that as I put the strips in here, that it's going to overflow the sides. It's going to get too big. So I'm actually going to set the frame aside. Notice that you actually have an index on your cube root rod. You've got the digits 1 through 9 on the far right-hand side. So we still have something to refer to in terms of what row we're working with. So we're going to set this up to be worked. 22 billion, 22 million, 635,627. We're going to split it into triplets using dots starting from the back. Put a line under the number and another line below that, and in between those two lines is where our answer is going to appear. Step one, as always, is to look at the cube root rod, find the largest perfect square that's not bigger than 22. Now, this is coming from just your first two columns. I will try not to be too repetitive in this video, but I've been a teacher for 35 years, so I tend to be a little repetitive. The closest perfect square here without going over is perfect cube is 2 cubed, which is 8. 27 is too big. It's bigger than 22. So the first part of our answer is a 2. When you cube a 2, you get an 8. And 22 minus 8 is 14. So that's basically our first step. Multiple parts, but basically step 1. To continue, we take the first digit of our answer, which is called the first quotumus by Napier. We multiply that by 3. Then we take that first quotumus and square it, which gives us a 4. 2 squared is 4. We multiply that by 3, which gives us a 12. If you're wondering about all this multiplying by 3, in the first video that I put up in taking cube roots, I talk a little bit about the algebra behind this. So you might want to look into that, and I'll link that as well. So what we're looking for here is the number closest to 14,022. I find the setup a little tricky to read, but I'm doing this exactly as Napier did it, so I want to stay true to that. So we're looking, again, on the left. We only want to go as far as the second column over on the cube root plate. And so as I look at that, I'm noticing that here we're in the 9,000s. It's ones, place, tens, hundreds, thousands. That's 9,000. If I take it one down more, I'm going to have a 10,000 here. So this is coming from row 9. And what it's giving me is a 9 in the ones place, 2 in the tens, and we get a 15. So carry the 1. 1 plus 1 plus 9 is 11. We augment the 9 with its square. So we have 819. We're going to put an 8 and a 1 in front of the 9. Now we move over to the right-hand side, to the back of the plate. We do 1 times this strip. 1 times 6 is 6. We write that so that's lined up with what we were multiplying by. Then I'm going to multiply 8 times what's here on the right. That gives us 48. Notice how I'm lining it up so that the ones place is under what I was multiplying by. Now, as I look at that, that's our final result that's supposed to be close to 14,022 without going over. And our result here is 16,389. So we're going to need to throw that out. So that's our first pitfall that we're coming across. Napier, I'm sure, chose this number on purpose to let you know that this can happen and what to do if it does happen. You simply move up to the row just above, and that will give you exactly what you need. So we're going to go up to row 8. As I look off to the left here, that's going to give us 2 in the ones place, 1 in the tens, so we get an 11, and carrying the 1 gives us a 10. We need to augment the 8 with its square, which is 64. And then I'm going to be multiplying on the right-hand side by the 4 and by the 6. Multiplying by 4 gives us 24, again lining up. Multiplying by 6 gives us 36, again lining up. When you add all of this up, you get 13,952. Don't forget what we're shooting for here. That is less than 14,022. So we write that on the bottom. And now we're going to need to subtract. Now normally I would want to do this by hand off to the side the way I normally subtract. Napier makes some comment in his writing about do this in the margin or something, but he doesn't show it. And I want to stick with exactly what he shows. 14,022 minus 13,952 is 70. And we write that above the next triple. So that came, by the way, that came from row 8. We need to write our next quotumus before we can move on. That came from row 8, so that's what we need to write. And now we're going to go through the same process of tripling and then squaring and tripling, but here's where things get messy. We're not just working with the 8. When you're working with square roots, you're always just working with the last number that you found. But with cube roots, using Napier's method, you're working with all of the quotumi that you have found so far. So what we're going to need to do is take the 28 and multiply that by 3. Okay, so we'll reset the board here. (28) times 3 gives us 84. It helps a bit to have some mental math tricks at hand. You can do your multiplication off of the back of this rod, and in fact you might want to for the next step, because what we need next is 28 squared times 3. You can just do 28 times 28, 28 times 28. Again, I'll put a link to the multiplication video, but that's not what this video is about. So I'm just going to work this one straight through. So again, 28 times 3 is what we want on the right-hand side, and that is 84. 28 squared times 3 is going to be 2,352. And we could have figured that out using the strips as well, the rods as well, but we're not going to take the time in this video. So at this point, what we're looking for on the left is 70,635. 70,635. And here's our ones place. So ones, tens, hundreds, thousands, 10,000s. You know what? Even in the first row, we are up to the 100,000s just by multiplying by 1. So I can't find something that's below 70,000. So what we're going to need to do here for our next quotumus is to write what Napier calls a cipher, which we call a 0. We go through the same steps again. We use all the preceding quotumi, and we do the same thing. Now, because it ends in 0, this isn't so bad. 280 times 3 is just 28 times 3 with a 0 on the back. 280 squared times 3 is just 2,352 with 2 zeros on the back. Okay. So now we're extending this to our final triplet. So we're looking for the closest thing that goes into 70,635. I'm sorry, 70,635,627. So the 70 followed by the next two triples. As we look along on here, we are going to find that in the third row. And I know that because I worked this out ahead of time and I don't want to prolong this. There's lots of steps here. So in the third row, on the left, what we find is a 7 in the ones place, and then a 2, and then a 0 and a 0, and a 6, and a 5, and a 10. So that's going to carry over, and I get 1 plus 6, which is 70. So we do get 70,560,027, which is close to but less than what we're looking for. We augment the 3 with its square, which is a 9. We multiply the number on the back by that 9, or we multiply these strips here by the 9. So that's going to give us 0 in the ones place, and then a 6, and a 5, and a 7. And notice that once again I've lined that up so the ones place is right under what I was multiplying by. So as we add, we get 70,635,627. That worked out. That goes in evenly. And so our final quotumus, the final digit of our answer, is 3. Therefore, the cube root of 22,635,627 is 2,803. One thing you might have noticed is that I ended up using 3 zeros. Sorry if part of that was off the screen as I was doing it. I used 3 zeros. If you purchase a set of Napier's rods, you're only going to get 2 of each digit, and typically that's enough. So I've purchased 2 sets, but you can also make your own. Napier's rods are just a multiplication table. Cut it into strips. You can make as many as you want. If you want something that's a little more hefty, a little more sturdy, you can make your own set, and you can just make as many digits as you want. If you're gluing cubes together, you can make digits all the way around, and Napier has a special way of doing that as well that has to do with 9's complement, perhaps the topic of another video. Thanks for watching.